Hey, Tom.
Thanks, Chris.
You know the previous assumption, or you want some more details?
Yep,
Ask
we're
them
good.
about that
Thanks,
while
Chris.
I'll be here. So take time to ask them during our lunchtime. Jeff, you good?
We're good.
Okay, turn it over to Jeff. Thank you.
Thank you, Dr. Smith. Well, welcome, everybody. It's good to see a nice crowd here again, and I'm happy to visit with you. I think we'll talk mostly today about temporary water systems because they really give you the most flexibility, and there's a reason why we're looking at flexibility is to try to learn where we maybe want to put permanent waters later on. So one of the things that we'll kind of think about with temporary systems is why would we even consider a temporary one? And it allows us to facilitate management in our grazing systems a little bit better. It may be some situations where I've got maybe a different crop that I'm going to come in with. We were talking just a while ago about some of the sorghum sedans and that, and maybe you're using that as part of a pasture innovation system. And you want to be able to come in there with just a temporary water system to try that out before you think about if I'm going to renovate that field and make it a permanent pasture, if it's just going to be part of a row crop system. The other thing is that in some situations we don't own the land, and so we may be limited. I know one of our specialists has a farm that he leases, and the owners won't let them invest in permanent water system. So there's another example of why we might consider a temporary water system to improve that grazing management. The other one is maybe we're not sure where the ideal location needs to be, and I've heard that more than once on some farms where we go there and we start talking to them and we visit, and they said, yeah, I've got this cost share money and I put that permanent water in there, and then realized after a few years that's probably not where I should have put it. So these temporary systems give you that opportunity to kind of test different areas on the farm of where maybe that water should be. And then also, it really does give us that maximum flexibility to help improve our grazing management by being able to put and take these systems at different places and then just move them, tear them down, move them to another spot, and continue to flow through those systems. There's a variety of things that are going to impact water consumption by animals, and that's one of the things I think we need to first kind of address is, you know, climate conditions. Is it cold? Is it hot? And you'll see that here in a minute. When it's hotter out, they require a whole lot more water than when it's cooler out. Obviously, the size of the animals. Sheep and goats aren't going to require as much water as beef cattle are. Stockers aren't going to consume as much water as a mature lactating cow. Stage of production is one of those. If you think about it too, on that dairy side, if you've got grazing dairy system and they're hitting peak lactation, 60, 80 pounds of milk a day, they're certainly going to have a higher water requirement than dry cows out there at that same point in time. Water quality is something we tend to not spend maybe as much time on as maybe we should, but there can be some impacts on water intake given some of our different mineral contents, particularly in our areas where we have maybe some higher iron in the soil that can go into that water and cause some issues with intake. Sulfur as well. Maybe not so much in this area, but in certain parts of the state we've got a lot of sulfur springs, and those can tie up copper along with that iron and make that unavailable to the animal. So there are some quality issues we want to maybe keep on top of. Feedstuffs, as we move now into winter, we're dealing with drier feeds because we're going to start feeding hay. With the drought, we've also maybe had to start feeding hay earlier than we wanted. But when we move from a wet pasture that's out here that's got about 80% water to that dry hay, that can influence how much water intake is going to be needed too. They'll get more of their water needs from that pasture that's got 80% water in it than they're going to out of that hay that only has about 10% water. And so think about those things. We can manipulate that a little bit too with some of the feedstuffs we have available. You're in kind of bourbon country or just outside of bourbon country, and there's a lot of stillage that's available. That stillage can be a source of water because it's running about 94% water, something like that. And so if you're bringing a lot of stillage in, what you'll typically see is water intake will tend to go down a little bit. All right, distance travel and frequencies of visitations is something to keep in the back of our mind as well when we're trying to start devising how we're going to get water to all the animals and what kind of system we need to put in place. Cattle will go long distances, and we'll talk a little bit more about that here in a minute, but we may not want them to go long distances if we want to increase our forage utilization. This table just simply shows you the differences in water needs as we look at temperatures, and this is just going from 40 to 80 degrees, and then I've got dry mature cows in the wintertime on the top, and then I've got lactating cows there, and then a set of, just kind of that stocker number, that 600-pound average. And what you'll see is that all of them will increase as we move from cooler temperatures to warmer temperatures. And then as we go from that dry cow to the lactating cow, you see that drastic increase in water needs. And so one thing people will say, well, how come there's nothing out here at 80 degrees? Well, very rarely do we have dry cows in the winter and it's 80 degrees, right? That would be more in your southern systems maybe. But we are typically dealing where we're weaning off these cows right about the last couple of weeks through now, and those cows are going to be dry, and guess what our temperatures are doing, right? They're falling. So we don't typically see that heat stress going through the winter on these spring calving systems, but it can influence it if you got fall calving cows as you go through there. Just keep that lactation part in the back of your mind, and that calf that's on the side of the cow too. These tables are out there. Every extension state, almost every state out there. We've got one that Dr. Higgins put together with some other folks, but almost every extension state has a publication out there about livestock water quality. And so this is just a summary that Dr. John Wagner out of Colorado State put together, looking at water quality issues. Particularly in Colorado, they've got some other, higher sulfate water issues to deal with out there. But there are some, typically when you look at the guidelines, they're generally going to show you that, generally considered safe and balanced diets. But there's these different tiers, if you will, and you just kind of have to be aware of maybe what species we're dealing with, goats, sheep, cattle, etc., and then what their acceptable tolerances are going to be, and they're going to differ also by stage of production. Feeder cattle may be able to tolerate more than pregnant cows, etc., some of those things. So it's important that you look at some of these tables and understand what those thresholds need to be. Nitrates, sulfates, total dissolved solids, do we have pathogens, blue-green algae concerns? There are a lot of things that can affect that water quality and have a detrimental impact on animal performance. And if you have water that you're suspicious of, you can get a sample of that water and send it off to a commercial lab and have it tested. We've got Dairy One that you can get bottles from. Rock River Lab, Cumberland, Waters here in the state will do a livestock water test as well. And so there's several places you can get that water and send it in. The key thing is to understand the changes that may occur. And so as an example, we just went through a really dry period, right? And so if you're pulling samples out of a pond, and now at my house we just got an inch of rain over the last couple days, you've recharged that pond a little bit, and so that may influence what your results will be after you had that rain. And so just keep in the back of your mind that these, depending on where you're getting water samples from, that they may change over time. In Lexington, for example, they will change where they're pulling water out of the river, and so it can actually influence what that water quality looks like from a mineral profile standpoint, depending on which pump house it's coming from. So I just want you to understand that a single sample in time is probably not the best way to do this. You want to think about multiple samples to capture that potential variability and just get you a range of where these things may be coming in at. All right, how far do you plan to take your temporary water system? That's where you really need to start thinking about laying out your grazing systems, because you really want to plan for the future and you want to plan for the longest distance you're going to go. In water systems, it's, how do you want to say it? We tend to not want to spend a lot of money up front, and so we restrict our potential distance we're going to go because we use a smaller diameter pipe than maybe we should have because it's a whole lot less. Typically, if you're going long distances, you really want to start out with a 2-inch pipe, and then you can work your way down the smaller inch and a half probably minimum kind of to start out with. And I'll show you a table here in a minute why that's important, because there is friction of that water moving through that pipe, and it will rob you of some of that pressure down at the end. So water pressure is one of those things that you want to keep an eye on too. At one of the farms we had, the water pressure was really high, and we kept blowing fittings. And so we wound up having to put a pressure reducer in on that system just to keep it from blowing the fittings off of the temporary water lines. And so that's a rare situation, but in some cases that can occur. And so you want to just be aware of that as you move through, and I'll show you a quick and easy way to do that. Pipe size is one of those big things that we already talked about. You know, I really don't know that there's a need to go much less than 1 inch. I get concerned about not having enough volume there, and what happens if the system gets turned off. You at least have a bigger amount of water still in the system. If you really need that, you can blow that water out into the tank, and a 1/2 inch is definitely off the table, and at least from a cattle standpoint. Also be aware of elevation changes depending on what you're trying to do and move water. You know, if you're trying to pump water up 200-300 feet, that's going to take a much different system than if you're going to gravity flow down. And so there are some opportunities to come in with solar pumps today. Solar pumps are not that expensive anymore. The cost on solar has really come down dramatically. Gas pumps. You know, I've been on several farms where we've developed spring boxes, and there's a holding tank up on the hill, and the farmer just will turn on that gas pump while he's out there checking fences, checking cows, and fill that nurse tank up at the top of the hill, and then when he gets ready to go, he just turns that gas pump off. So there are some technologies out there that often maybe we don't think about being at our fingertips that we can use to help offset some of these elevation challenges. So they differ from permanent systems because we're typically wanting to move the system as we go. And so the equipment that we use are going to be tanks, they're going to be floats, and they're going to be pipe. There's also the hope that in these systems that we're going to design it where the cattle or livestock are going to come at smaller batches, smaller numbers, rather than the whole herd at once. So we're changing the visitation behavior. Whereas in larger travel distances, the whole herd tends to migrate with everybody at once. The boss cows get up there and drink a lot, and then as the boss cows start to go away, some of these more timid cows will come in and start drinking. And in those situations, then you're putting a lot of water consumption demand on that system in a short period of time. So in these temporary systems in our area where we're dealing with smaller farm settings and subdivisions, we're going to see more visitations per day. And 4 to 8 visitations to a water a day is not uncommon in 20-acre fields or 30-acre fields. And so they're going to come in and eat or drink smaller volumes of water at a given time so we can get by with smaller tanks. You need high flow rates, though, to recharge, especially if you're trying to use little tanks like this one shown down here. This is just a 60-gallon tank. So in order to keep that tank filling back quick enough that it doesn't get sucked down to the point that they will tip it over or break your valve off, you've got to have a high volume of flow going into there, which requires both high pressure and a valve that will allow high volumes to flow. If you want to try to be a portable system, the tanks also need to be manageable. What do I mean by that? You've got to be able to empty them out relatively easily. They can't be these 1,000-gallon poly tanks that you can't tip, or you're going to have to wait for it to drain, and then you're wasting water and those types of things. So in a lot of our temporary grazing systems that we're putting up with these systems, probably nothing more than about a 200, 300-gallon tank to be able to manage getting it emptied, and then not spending a lot of time waiting for it to drain down, and then just physically being able to lift it up on the back of the truck or the UTV and being able to move it. You can get creative and you can mount those onto like pallets or some kind of drag system, or on a old kind of wheel-based system. and you can pull it that way, but just think about how you're going to manage the volume of water in there and get rid of that water. Also, generally, these temporary systems are not designed to be freeze-proof, though there are some people that have gotten really creative, and you can have some of these systems that will not freeze, but the challenge with them is most of them are relying on where you've got continual water in and an overflow. And so that excess water has got to go somewhere. With the concerns about water availability as we move forward and quote unquote trying to reduce our water wastage, I'm not sure that having something that's continuing flowing, unless it's coming out of a spring, that you can then just discharge that water back down into a stream or something like that, that's the way we want to go. Particularly not if you're on municipal water, you don't want it continually running, because I'll show you some numbers here where that will get pretty costly. All right, when you start thinking about daily water needs and kind of flow rates and tank sizes, how many animals are you going to be dealing with and how much are they going to consume? That's where that table helps to come in to start doing your planning. And don't forget about the calves that are on the side of the cow, particularly as they get closer to weaning, because they can be consuming 6 to 10 gallons of water a day as well. How many times are they going to visit a day? What percent of the animals do you want, or will they actually be able to drink out at a time? You know, if you've got a herd of 30 cows and they're coming into a tank, it takes a big tank for all 30 cows to drink at one time, right? And so in these systems, again, where we're having small fields, we're not expecting probably more than about 10 or 15% of the animals to be coming up at any given time to be drinking out of the tank. So our linear foot, or even in a round tank, the amount of space that we need around that tank doesn't have to be as extreme as when we're dealing with further distances that they travel. All right, and then also, how long does it take for that tank to recharge? If we look at some of the data that's been reported on water frequency visits, or water frequencies, in other words, the time at which cattle will come to a water and drink, in confined dairies, we're in basically a tie stall barn. They've got to go lay down, they get up, they go eat, and they go to water, and then twice a day they go to the milk parlor. That's all they've got really to do. In those scenarios, in confinement dairies, they'll see cows go up to the water and drink a little bit of water up to about 14 times a day. Okay, part of that is they're just moving through the system, they're going to get feed, they're going to go lay down, they go by water troughs that are on each end of the barns, and they'll stick their head in and get it. In grazing dairy cows, they have observed up to 7 times visitation. But also remember, even there, they're moving those cattle off of pasture at least 2 times a day up to the parlor, so they're likely going past waters, and they're also likely standing in an area that has a water before they go in or where they come out of that parlor. If we look at some of the Australia work in the really extensive backcountry of Australia, they have observed that in those situations, cattle may not come to a water source but once every 3 days. And so that's a lot different situation, isn't it? And so Dr. Gill, probably in his part of the world, I mean, it may be one every day, they come up once a day, maybe once every other day, may not be uncommon, but I just want you to understand the appreciation of the variability in frequencies and how that tank size needs to be able to accommodate that based on the size of pastures that you're really talking about. In the U.S., there was some work done looking at pastures that were roughly 20 acres in size, and in those 20-acre fields, they observed anywhere from about 2 to 6 times visitation. And the actual average, when you do the math and looked at the individual animals that came in, it averaged about 2.4, which, wondering how do you get 0.4 visitations? So it's somewhere between 2 to 3 times a day in fields that are around 20 acres in size, that an animal is going to come up and drink water. And so that's something to keep in the back of our mind. If a cow's going to consume 20 gallons a day, and they're going to come to the tank twice a day, then that means she's going to consume roughly 10 gallons at a time. And that's very different than if I've got a cow that's coming to that tank 5 or 6 times a day, right? And so the volume of water coming into the tank and the size of the tank is going to be different in some of these scenarios. And I just want you to understand that. I have moved away from the little tanks because that, in our systems, what I have seen is that we are trying to manage a little bit bigger pastures, and there's not the 3 or 4 coming at once. It's bigger groups, and they drink the tank down too fast, and they tip the tank over, or they step into the tank on our really hot days because they're trying to cool off, and they'll step on the daggone valves and break the valves. And so by having a little larger volume of water, it prevents them from tipping the tank over, and then you need to think about potentially building some kind of safety cage over your valves to protect them from getting broken. Having water in every grazing paddock leads to smaller numbers coming at a time compared to having waters in the lane. I like lanes to a certain extent, but I'll be honest, I'm not a huge lane fan unless it's a dairy system because you're losing a lot of manure nutrients in that lane as well. It's not being evenly distributed out on the pasture. Some work that was done by Missouri also showed that if you had water in every pasture, you also saw greater dry matter consumption of the forages. And so they're spending less time going into the lane. You know, they're going to be out there grazing and that. And so if they go in the lane, they're going to overgraze the lane and walk the lane down. And so we actually see greater dry matter intake if you've got water in every paddock versus having them go into a lane. This is that little pressure tester. It just is, you can screw that onto the end of your line where the valve is going to be, and you can get an idea what kind of water pressure you're having at the valve itself. They're only about $20-30 at most, but that's a good little useful tool just to kind of see what your water pressure is down there actually at the tank where you're going to be putting your valves on. Trough volumes, some of the recommendations. This is a nice little pub on water system designs. A minimum of 2 gallons per animal. So if we're dealing with kind of 20 pairs, think about you've got potentially 40 gallons for the mature animals, and if we use half of that for the calf, you've got an additional 20 gallons, so you need a minimum of a 60-gallon trough volume. But that number is really small. I have used a 60-gallon tank on up as many about 45 head of stockers and have gotten by with it, but you got to have good flow and you got to have good pressure to keep that thing working. Another way to think about it is kind of think about the flow rate to make sure that you've got sufficient flow rate coming in to completely fill that tank within an hour. So if you've got a 200-gallon tank and you want that to fill within 60 minutes, you need at least 3 gallons per minute. The general rule of thumb is typically somewhere near 6 gallons per minute. If you've got 6 gallons per minute flow rate, you probably will never have an issue with tanks not filling up fast enough. If you do some of the math in some of our smaller groups, you'll see that you can get by with down around 2 gallons per minute, but that would be really putting a situation where only a few animals are coming up, maybe 10% of the group at a time, and you've not got a lot of animals out there. So just be kind of thinking about some of these criteria as you move through developing your temporary systems. Pressure, generally they're looking at 3 psi per gallon minute flow rates. So as an example, if I had a 4 gallon minute flow rate times that 3 psi, that would give me a pressure of about 12 psi where I'm putting the float on. That's kind of the bare minimum. If you want that to be 6 gallons or you've got actually 6 gallons per minute, then that pressure at that float would be about 18. And so that's where this tool comes in handy to be able to put that right there down where your float valve's going to go on and see what kind of pressure you've got out there. And that's important because some of these floats have specific requirements at which they work best at. I encourage you to work with NRCS and our ag engineers if you're thinking about developing a water system to make sure it's going to work well for you so that you don't run into some problems. Municipal water comes at a cost. This is for my county, and these are numbers from this year. Just to give you a rough idea, these are the numbers that we're dealing with. So then if I've got a 50-cow herd and I've got 47 calves with 2 bulls running out there, In the summertime, in a spring calving herd, it comes up costing me just under about $200 a month to water the cattle. That's not inexpensive. And if you have a water line break or something with a float that sticks open and it runs 200,000-300,000 gallons out before you get out there, that can be a real big pocketbook hit. In the wintertime, it's about half of that because we've sold off the calves and we're not bringing the calves through the winter. And in those cooler months, the cows don't require quite as much, but it's still almost $100 a month for me to run on municipal water. And so that's why I think it's a good opportunity for us to work within our CS to think about developing maybe some springs or controlled access into some streams where it's appropriate, and think about some of these alternative waters. And it's always good to have a backup, and we'll talk about that in a minute as well. Don't forget, you've got cost of lines and drinkers that you've got to invest in those systems too, but we're very fortunate that we can get cost share money for that. And so we can have that offset by plugging into some of our cost share programs. Even the County Cape money can be used for some of these things. All right, let's talk real quick about float valves. These are the kind of the ones that are widely available, not that expensive, that folks will get their hands on. And when you read the advertisements, they look really good, right? Because they say flow rates up to 245 gallons per hour. But if you do the math real quick on those, then you're looking at a 4 gallon per minute max. And you've probably seen those, you know, the right? And so they're really limited on how much flow they'll actually push out on those. They also state that they operate between 20 and 50 psi, and so that's something to keep in consideration. Low psi just may be an issue because your flow rate's going to be even less. And so if you've got really low pressure, you're not going to have as much water going into that tank, and they greater opportunity for them to drink it down and tip it over.
Do you know what a municipal water system is for PSI?
About at your house, it will be probably between 40 and 60 psi. If you were to go outside on your house spigot and open it and put that on there, I wouldn't be surprised if it comes in at 50 to 60 psi. Yeah. And they all vary and from town to town and where you're at, but that's not uncommon. One of the things I don't like about these is because you've got the garden hose that screws in the top of those, they will find that attractive and something to play with, and they'll want to try to grab a hold of that. And so you need to think about trying to protect or prevent them from grabbing a hold of that. And the other thing is, as we move into this kind of weather where we've had some frost and it's starting, tomorrow we were just saying it's going to get down in the 20s, and you get a little bit of ice coming on the surface of those tanks, it can freeze those valves, and sometimes they'll be running and they'll start freezing and they'll actually kind of push down a little and they'll keep running, or they'll push up and they'll lock, and the cattle will drink out here and they'll drink the tank down and the valve's still stuck closed, and then the tank gets empty and they tip it over, and then finally they step on the valve and they break it. Not that I've ever had this happen. And then you've got a mess when you come back out after work in the night. So this is kind of to show you where things can go wrong. There's a couple things that went wrong. One is the water's put in the shade, right? And so when you put water in the shade and cattle want to go in the shade to loaf, then they can stand around there and play with things and make things a mess, right? And so then as you look at this, you know, they actually pulled the whole thing out, and it's just been running on the backside for who knows how long. Okay? And so that's where I don't care for these, and I can honestly say, yes, this was in my place, so do as I say, not as I do, right? But, you know, in that situation, we needed something quick, and that was all that was available locally, so we just went and got it because the spring dried up, and I had to get water out there to the cattle, and that's all I could find locally. Hudson valves, I like Hudson valves a little bit better, and the reason for that, this is kind of the flow chart. This is PSI and pressure down here, and this is a gallon per minute flow rate. So with a 1-inch valve at about 10 PSI, you're getting about up to 31 gallon per minute flow rate. And so they can have relatively high flows at low pressures. They're kind of a small float design, so they don't take up a lot of area in the tank. And you can actually use piping to plumb those in, and so it could be a little bit more rigid, and the cattle, you can secure that down on that tank a lot better where the cattle won't pull it out and destroy it. They're pretty easy to mount. You can do it yourself with some brackets, or they actually do sell some brackets for those. One of the downsides is they do have a filter in them that will get clogged with silt. So if you're using like pond water, or you're using some springs that aren't super clean, they will silt closed on that filter, and you got to take them apart and clean that filter. And the filter is actually kind of up on the top of those. They also will freeze because they've got a float in the bottom, and so there is the potential for that float to freeze. The bottom mount valves, there's several companies out there that have bottom mounts. This is one of Gallagher's. This is the Apex. This is the Mega Flow by Job. A lot of they've got a large range. A lot of these will work at very low PSIs. That's what makes these kind of nice. 5 to 150 PSI working range on a lot of these, so you can get really low pressures and still get these valves to work appropriately. But yet they've got pretty high volume flows. The dark black line here is for the 1 inch and 1 1/4 inch. They make them down as small as a 1/2 inch for like small ruminants. But again, if you look at these at 10 PSI, if we're comparing back to the Hudson, you still get about 23 gallon per minute flow on that 1 inch valve at 10 PSI. And so you can get a fast recharge rate in these tanks with these types of valves. There's a bottom mount, and so you're working with the valve being down here and a float tied to them, and as the water level rises, then it pulls that valve shut. And so there's less chance of them getting a hold of that and causing damage. But if the tank gets down really low, they can see that string down there, and they will wrap their tongue around that string, and they will either pull that float apart or they'll break that float off. So just be aware of some of the challenges with these as well. There isn't really, again, these have a filter in them, and I have had issues with algae growth in them clogging that filter up, but they're quick to take apart. You just basically a 1/4 turn, pull them off, pull that filter out, rub it in the tank, put it back together, and it's good to go. So they're kind of easy from a cleaning and maintenance standpoint. The old bob valves, a lot of you have probably had those or have seen those. They're in a lot of our old concrete tanks and that, but they can be used in these tanks as well, and sometimes we forget about them. You can reinforce the side of these poly tanks with like an old plastic barrel to give you a little bit more thickness to be able to boat through on these. But they can be used in these tanks. They're relatively inexpensive compared to some of the other ones. The only thing with these is, you know, they run that metal rod out. There's basically a 1/4 inch rod that screws in here, and that goes out, and then there's that typical silver or black bob that goes on there, and then it fills up just like your toilet tank, and it shuts off. But you can take that and cut that rod off. Most of them are brass, and you can flatten that down and drill a hole through, and then you can tie one of those floating valves on there to give you some flex. And so that way what you have is not something that's completely rigid. Sometimes you've probably seen them too, where you've gone in there and maybe a calf has gotten into the tank and they've broken that rod off. And so now you're sitting there in the middle of the field and the water's still running. Just think about that. Grab an old, sometimes it can be just like a couple of water bottles that you got in the back of your truck that are empty. It will float with the water, and you can tie some baling twine around it or something and get that to come up until you can go to town and get a different float. So the nice thing about these two is you can buy them in different flow volumes. They come in as low as like a 3/8, that's only about 11 gallons per minute. You can get some at 21 gallons per minute at 35 PSI. There are bigger ones that have a higher flow rate. So you can get different sizes to fit your systems, and they're relatively low maintenance. That's the beauty. They don't have a filter in them. They work pretty easy, and they are bottom mounted as well. And so it's not that hard to put these in. Tanks, real quick. When you think about cattle at least, and you need to think about what you're dealing with Greg will be with multi-species. I'm sure some of the lambs and the sheep are going to require a shorter tank than what we're dealing with here with cattle. With cattle, we typically say throat height shouldn't be more than about 24 inches so that they can reach over that 24-inch tank and reach down to the bottom of the tank if they need to, and then also thinking about those calves, and the calves being able to reach in there and get water in that tank. The tanks also need to be light enough that you can pick them up and move them. This tank up here, which is about a 300-gallon tank, empty, weighs about 65 pounds. So easy to get up, pick up, and put on the back of a UTV or in the back of the bed of a truck. So just be thinking about that. Also, think about how you're going to set these up. So in this situation, you'll see there's a drain down here. But if you want cattle to be able to drink out of both sides and on the end, then think about putting this side, and that's where that temporary electric fence is really nice, because you could plumb your valve in on this side, run your electric fence just right over the top of this, and protect them from stepping on the back side of that tank and breaking off the line going to the valve itself. So be thinking about how you're going to set these out to make sure you've got enough area for the cattle to come in and drink out of. Lastly, thinking about water placement. I don't even know how I'm doing on time, Chris. I think I got 5 minutes left. All right, water placement. Centrally located is ideal. All right, because if we're centrally located, animals are going to overutilize the forages closest to the water. They're frequently coming here to get water, and so if it's more centrally located, there's going to be opportunities for them to graze to the backs of the fields more uniformly than if we have it up in a corner. Here again, they're going to overgraze this part of the field. These squares are exactly the same size, and they're going to underutilize the forage back here because they don't want to travel back there and travel as far away from the waters. So ideally, it would be centrally located if we can. And this is just a good example. Kevin Laurent put this together a few years ago. And as we think about it, if you've got cattle that are coming here to a water source, whether it be a pond or any type of water source, these areas tend to get overgrazed. You tend to get a lot more manure deposits here. And so you're actually bringing nutrients from the forages and the soil from here, and they're getting concentrated down here. And we've got the data from the Princeton station to support this. Significant differences in the soil phosphorus levels, much higher concentrations out here close to the water compared to out here further away. And so that's one thing to think about. Not only are we trying to get even grazing distribution, but then subsequently we're trying to get even manure nutrient distribution. And so that's where that water in the central location is kind of key. This is a farm just randomly that I pulled up that's wanted to show you the common mistake. This has got a field over here that has a pond with access. To me, this appears to be the hay field. Here's a pond down here, here's a pond down here, and when I zoomed in, the cattle were, this is a fenced out pond, but the cattle were actually all in here in the fence, so they're probably just grazing it down. Not that anybody would ever fence a pond in and leave it wide open for cattle to have access all the time, because we don't do that, right? But here's the critical mistake. One water point only on the entire farm. This was the only water point in the entire farm. And so when you start looking at distances, we usually say if you keep your water distance and the edge of the field at 800 feet or less, you will maximize manure nutrient distribution and forage utilization. And so these cattle are going to have to come down here. They're going to get water out of the pond, but where are these cattle going to get water? Likely from this stream down here, as long as there's water flowing down through here. They probably are going down and drinking that water. But you could easily correct that. This is 800 feet to the corner down here. This field's only 700 feet, about 750 feet from point to point. By investing a little bit of money into some lines, I know our previous speaker doesn't like them in the fences. However, if you're really on a budget and you don't want to put water here, here, and here, you can share that fence line, but like he said, it's going to put more pressure on it. But you can have basically a quick disconnect right here with black pipe on the top. Then once you're done with these two fields, you can take that tank, move it over here, plug into the quick disconnect over here, and then get water to this field as well. But that's just a quick and easy fix. Doesn't cost a lot. With the cost of poly pipe is about 75 cents a foot. So That's total about 1,200 feet, so you're looking at about $1,300 to improve your water systems there with a temporary water pipe and tank and float and all that. Now, why did I say don't go much less than 1.5 inches? If you look here, if you've got 6 gallon per minute flow rate, this is the friction loss in PSI for pipe that's either 3/4 inch, this is that black poly pipe, 1 inch, 1.5 inches, and I just did the 1 inch to 3/4 inch because you think, oh, that's not that big of a deal. But that's over a 3-fold difference in loss and pressure. And so if you're going that 1,200 span, I'm losing 41 PSI to friction in the 3/4 inch versus only 12 PSI in that 1 inch. And so that's where starting off big is really important. If you look at the 1.5 inches, you almost have no friction loss in the 1.5 inches. And so that's pretty key when you're starting to think about how far you're going to go. And then lastly, temporary solutions can be quite creative. And a lot of farmers have played with these and have gotten really good. These are some systems that have been developed up in Canada. The tank and storage tank are all together. There's a solar pump that goes on that. They run a line then to a stream or to a wellhead, and then the solar pump just pulls the water into the nurse tank, and then that feeds that trough. And when they're ready to move the cattle, they can just dump that out. They don't turn the pump on for a while and let the nurse tank come down, and then they can move that whole system somewhere else. This is another quick example of a smaller unit that's got your solar pump built in, the batteries underneath. This all kind of goes along a fence line, and you can protect that with a poly wire. But that's about I think that's about a 600-gallon tank on that, just to give you reference. So the prices on solar have come down so much that these systems are really becoming probably a little more affordable. And there's even these collapsible tanks now that are made out of fabric that the fire departments will use. They'll come up to 1,000 gallons. And so you can use this portable tank, fill it up, and then when you're done, you empty it out, and then you can just collapse it down and throw it on the back of the truck and haul it away and move it to the next spot. With that, I think my time is up. Any quick questions? Awesome. I bored you to sleep.
Excellent information, Jeff.
Thank
Will
you
be
all.
around all day?
Yes, I will be around.
Yeah, quick question here, Jeff, as we're switching over.
When do you see a loss in consumption of cattle?
Yeah, so the question is I think your question is there an ideal water temperature for cattle? Is that kind of where you're...
A reduced intake as the water temperature increases. You're looking at 90 degrees or something.
Yep. So the rumen's like a 101, right? But if you look at the water temp data, they will say that when water temperatures, the ideal water temperature upper end is around 70. And so when water temperatures start getting up above that, you can potentially see some decreases in water intake, but they're really marginal. Yep. I don't know the answer to that. I'm sure there is a critical point. Dr. Gill, do you know? I really don't think there probably is. If they have to have water, they're going to consume water. I don't know. I'll go back and look and see if there's actually an upper threshold on water temperature.